Hello, I'd like to discuss using Altium for schematic entry and circuit layout. Altium is a very large tool and there are a lot of features in it. In this video we will only be covering some of the basics. The first step is to click this picture of a person and click sign in. You should use the sign in credentials that you set up with your email. Click sign in. The next step will be to go to Manage Licenses and scroll down to Private Server. You should take one of the licenses and you can either right click it and click Use, or you can left click it and then left click the Use button. So once it says that you have a license that's used by you, you can close the License Management tab and we're going to make a new project. You should see this project's panel in the left side of your screen, but if you don't, you can click panels in the lower right hand corner and then click projects. So that will make it appear or disappear. Now right click the top of your project tree and click add new project. You should select PCB default and then give your project a name that you find relevant. So I'm going to name mine accelerometer. And then I'm saving it in my Altium projects folder. You should save yours in a folder on your S drive and click create. So now we have a new project, but we don't have any files in our project folder. So if we right click on that project and we can click add new to project, and we're going to start with a schematic. So now we have a blank schematic and we need to add components. There are a few ways to add components. One is this place part icon, and you'll see these components show up in the right hand side, and you can choose various libraries. Now you'll have these two libraries, the miscellaneous connectors library and the miscellaneous devices library, installed by default. So you can scroll through and you'll see that there are plenty of parts. I'm going to close this tab and I'm going to click Panels, Explorer, and in the Explorer panel we can search for a large number of components that are on the Altium Online Vault. And the first part that I want to add is the ADXL335. So we can expand this panel and we'll see that we have a few different options, but they all look the same. The difference being these last few characters, RL or RL7, signify that the component comes on a reel. So it's the same exact component, but the method of shipping and the packaging are different. So I'm going to right click on the part that I want, click place, and choose part A. I'll bring my cursor over into the schematic and I'll left click once, and you'll see now that the part B of this schematic symbol is now available, and I'll click again. And now we have another part A, so if you wanted multiple iterations you can keep clicking and keep placing ADXL335s, but I'm going to hit escape because I only need one. These two schematic symbols are part of the same footprint. So you need the A and the B, and sometimes you will, or a manufacturer will, divide their symbol for readability purposes. The next component that I want to add is the LP2980 AIM, and we're going to choose the 3.3 volt version of it. So I'm going to expand this name tab and scroll down and find a 3.3 volt version of it. And once again I'll right click it, I'll click place, and I'll put that on my schematic. And you'll see that this schematic symbol only has one part to the symbol, and I'll hit escape to stop placing it. The next component that I want to add is not in the Altium Content Vault. So that component is this header. It's a 7-pin header, and if I search, you'll see that it's not found. So when you have a component that you need to add and it's not in one of the pre-installed libraries or the Altium Online Content Vault, you have two choices. One is to make your own schematic symbol and footprint, which we will not be covering in this video, but you can find other videos online to show you how to do that. Or you can use a tool, a website called SnapEDA. So if you go to SnapEDA, you'll need to make a free online login. I already have one made. And you can search for your component here. So they have the component that I'm looking for. And here in the data available, you can see that it has both a symbol, has a footprint, has a 3D model, and a data sheet. Really, these are the two important ones that you're looking that it has a symbol and a footprint available. Click the symbol for symbol available. And you can see what the symbol will look like and what the footprint will look like. And choose Download Symbol and Footprint and select Altium. So I'm going to save this file. And if you forget the next steps, you can always click this Learn How to Import tab. But we don't need that right now, so I'm going to browse to where I've downloaded the folder. And I'm going to unzip the folder somewhere where I'll have continual access to it. So extract all, and I'm going to choose C, users. And choose my public folder and my public documents and save it to Altium. So I've selected that folder. I'm going to extract this library, and here we go. Now the part that we just downloaded is this 640383-7LIA, and the LIA is a library file. So let's make sure you save where you've extracted your file, and we'll go back to Altium and go to File, Import Wizard, wait for the wizard to load, click Next, choose PCAD Designs and Library Files, Next. We don't have any design files, so we'll just click Next, but we do have a PCAD library file. Go to Add and navigate to where you've just unpacked the library. Choose the library that you want to install and click Next until you've reached the end of these dialog boxes. Here you might in the future want to edit some of the layers that it's going to import, but for right now I'm going to accept the defaults. And I'll click Finish when I'm done. So you'll see here that your library is now an available source document. I'm going to move the size of my panel, and I'll click the place part that I showed you before. So it's this icon right here that looks like a component. In the top right, I will select the library that I just installed. And so we can go to the integrated library, and that's INTLIB. Right click on the part and click Place. And so that's the majority of the components that we need, but we'll still need some passive capacitors. At this point, you could choose a very specific capacitor made by a particular manufacturer at a specific value, or what I'm going to do is put a generic capacitor down that has a specific size but no specific value or manufacturer, and I can specify that later on my bill of materials if I'm getting it outsourced, or if I'm assembling it myself, I can just use whatever components that I choose to buy. So I'll go back to the Explorer panel, so click Panels, Explorers, and I'm going to expand that screen again, and I'll go to Folders. I'm going to go to Unified Components, Components Generic, Capacitors, Basic Surface Mount, or Generic Chip. Basic Surface Mount will have some of the manufacturer filled out. And I'm going to choose the size 0603, cap 0603. The name implies the size, but also the description will tell you the size. So I'll right click, and I'll click place, and I'll move over in my schematic. And to rotate a component, before you've placed it, you can press the space bar. And then keep clicking on the screen for as many capacitors as you plan to use. You can always copy and paste a component later or go back and add it from scratch. So at this point I have all of the components that I plan to use for the board, and you can go to view zoom and you can fit all objects or zoom to a specific area. There are a lot of tips and tricks into using Altium, but they'll go beyond the scope of this video. So how do I hook up my components to one another to designate what electrical connections I'm hoping to make? So you can use this bus bar. It's a place wire. You can hit Control W or click this icon. We're going to start by laying out our grounds. So I'll click this ground, and I'm going to click the top of this pin 3, and I'll drag the symbol down. And if you zoom in, you can see that here where there's a 3-way or more connection, a dot will appear. To make it more readable, I'm going to select all of those wires and the actual ground symbol and drag them out. I've also accidentally selected the component, so I'll hold down Control and I'll just deselect the component. And so that allows me just to select the wires. Now if you drag from the lower right to the upper left, you'll select everything that your bounding box touches. If you select from the upper left to the lower right, now you've only selected things that are 100% within your bounding box. I have a few more grounds to place, so I'll place one here. And I'll hit Escape to leave the placement tool, and I'm just going to move by clicking this name, which was in the way. And I'll just check my notes. Pin 3 of our header is also going to be ground. It's a good idea to lay out your circuit in a way that is human readable. It's important because if somebody thinks that something is connected and it's not, you might not have a working circuit in the end. I'm going to connect the power in a slightly different way. We have an input here in this DC-DC converter that should be 5 volts. I'll first just make a wire and hit Escape. And then I'll go to Place, Net Label. And it's important that the X or the crosshair ends up on this wire. And I'll click once and I'll hit Escape. Double click the net label, and on the right you can type in a net label that you want, plus 5 volts, and hit enter. So now anything with this net label will be connected together electrically, even though it doesn't show a wire connecting it. So I'm going to select that net label and the wire, and I'm going to also place it on pin 1. So we'll have 5 volts coming in from off the board, and it will power this DC-DC converter. Now I'm going to just move this over to keep my drawing neat, and I'm going to go to Place Wire, and I'll connect the 2 VS's, and I'll connect the output, which is 3.3 volts, to these VS's. And I'll hit Escape to leave that wire drawing tool. And if I hold Control and use the scroll wheel, I can zoom in. And I'm going to move this wire just to make it more readable. So right now we have 5 volts coming in from off the board, going through the DC-DC converter, becoming 3.3 volts here at VS, and then powering this accelerometer chip. So I want to connect this 3.3 volts also to a pin in case we need 3.3 volts somewhere else on the wire. So I'm going to go back to Place, Net Label. I'll press the space bar to rotate this net label, hit Escape to leave that tool, double click it, and I'm going to write plus 3.3 volts. And I can select that net label, Control C, Control V, press spacebar to rotate it around, place it where I want, and then connect it with a wire to pin 2. And hit Escape. Alright, so we are making the rest of the connections. I'm going to place a wire, and pin 3 will get connected to pin 1 and hit Escape. ST is our test pin, and that will get connected to pin 7. Now, if you start wiring, all over the place like this, you might see that your schematic gets pretty messy. So I'm going to delete that wire for now, and maybe I'll use a net label later. But we'll see first how these connections to the rest of the chip go. So if I look at my planned schematic, I have pin 4 going to Z out, pin 5 going to Y out, and pin 6 going to X out. So I'm going to mirror this component. I will select everything that I want to mirror, and as I start to move it, I can press X to mirror it around the in the X direction, mirror it around the Y. So now maybe my layout will be a little neater. So I'll start wiring. We have 6 goes to X out, 5 goes to Y out, and 4 goes to Z out. And pin 7 will go to test. So there's a few more things that we need to wire. We need a VS to ground here, and so I'll add another ground. We need a 5 volts to ground there. Each X out, Y out, and Z out needs a capacitor to ground. And you can arrange this however you'd like. So if you zoom in, you'll see that when these wires cross, they don't make an electrical connection. There's no round dot. But that doesn't mean that this is the best way to do it. There could be more readable solutions. So let's see, how I can come up with a more readable solution. How about something like that, maybe? You can always delete by clicking on a wire and pressing the delete button and then rewiring it as appropriately. I'm going to delete this for now. And So at this point we have the same electrical connection that we previously had, but I believe that this is more readable. That is a subjective assessment, and it's up to you to decide what is the most readable way to make your schematic. It will help other people who are going to use your project in the future or who are going to review your project in the short term. Alright, and we needed one more capacitor. So we already have a capacitor between this net and ground, but I want two in my final board. One will be close to this component and one will be close to this component. Great, and then the last step is to handle these no connect pins. If you don't do anything with these no connect pins, you can still make a fully functional PCB, but you will get errors when you run your design rule check. So what I can do is right click anywhere on the schematic and go to place and go to directives and click generic no ERC, and ERC is error rules check. So by placing these no ERC indicators on these pins, we won't generate any errors related to these pins not being connected to anything. Alright, so this is our schematic. We have to add a few things like a title. So if you click this place text string, I'm going to write that by double clicking it. This is the accelerometer demo. And you could put your name and any other information you want. And then we can center everything, so I'll just select my whole circuit and put it in the center of this page. Okay, so you'll see that we need to give each component a unique identifier. And so to do that, first make sure everything is saved and your schematic is saved. And go to Tools, Annotations, Annotate Schematics. Click Update Change List, OK. Accept changes, validate changes, execute changes, close, and close. And you'll see now that each of our parts has a unique identifier. All of our caps are numbered uniquely. Our parts U1 and U2 and J1 for the connector. So click Save again. You can use Control S for File Save. Save the whole project. And now we're ready for layout. So right click on your project, add new to project, PCB. First we will save our PCB document with the same name that we used previously for our schematic, but we're going to change the file type to PCB doc. So click Save. I've already had something there, but you probably won't. And now we'll import a DXF file that we'll use as our board outline. So go to File, Import DXF DWG, and scroll to where you found your DWG file. And make sure that you choose the correct scale. In this case, I designed in inches. And we want to import a mechanical layer 1. You might use a different layer. As long as your board manufacturer knows which is your outline, you can use any mechanical layer. So you can ignore this warning for right now. We need to delete these educational messages on the bottom. The next thing I want to do is move the origin, and I'll go to Edit, Origin, and click Set. I'll zoom in and I'll set it to the lower left-hand corner of my board. Now select the entirety of the board outline and go to Design, Board Shape, Define from Selected Object. Now we want to import our parts from the schematic. So go to Design, Import Changes from Accelerometer PRJ PCB, and click Validate Changes, Execute Changes, Close, and you'll see here are all of our parts. You can delete this red box by clicking it and pressing delete. So now you'll notice that J1 is way too big. I inserted the wrong part. There's a few ways that you could go about fixing this. The easiest one is to go back to your schematic and then add the correct component back. I'll go to File, Import Wizard. I'll click Next. I'll go to the PCAD library files. I'll add the file that I'm looking for. It's this 826 file. I'll click Next. And here you can choose which layers you want. I'll just get the top and the bottom layer, and I'll click Next. And I'll click Finish. So then I'll navigate to the integrated library for the file that I want, and it's this 826937 integrated library. And I'll right click on the part and I'll click Place. And here the schematic symbol is slightly different, but it's for the correct part. So I will cut and paste this other part for reference as I re-hook up the symbols that I want. So I'll select this 5 volts and I'll put it here. I'll move this, and remember, if I hit spacebar it will rotate it if you need. I'm going to delete that, and I'll drag this and I'll press spacebar. And then 4, 5, 6, and 7 are still laid out the way that they were before, so I'll highlight the whole connector and I'll make my connection. So now I'll delete this old part. Click Save. Make sure your project is also saved. We're going to need to re-annotate. So Tools, Annotation, Annotate Schematics. Annotation failed. It's probably because this file wasn't saved. So we'll go back here, Tools, Annotate, Annotate Schematics, Update Change Lists, Accept Changes, Validate Changes, Execute Changes, Close, and Close. So now we can save this document again, save our project again, and go to the PCB document. So this still has the old part on it. What we need to do is go to Design, Import Changes, and so it's going to say, it failed to match one of the 9 components because this component is no longer on the schematic. So let's automatically change, click Yes, Validate, Execute, Close, and just delete that red box again, and now we have a new component and it fits on our board. So that's great. So now we can go and complete the rest of our layout. So you can take these components, and what you see here, these air wires will show you what electrical connections need to be made. And you can rotate components to see how they might best fit. Sorry, I am hitting my Windows button by accident instead of the Control button. And you can drag your components and rotate them using the spacebar. So this is an iterative process, and you'll probably need to, move components as time goes on. Especially on small boards like this, the overlay might be getting in your way. The overlay are these silkscreen words. So if you press the L button for layer, And where it says top overlay, you can press the I and it will hide those. It doesn't delete them, they're still there, but for the time being they'll be out of your way. So as we start to lay this board out, it's important to choose whatever rules you want. So you can go to Tools or Design Rules, and I'm going to change some of my rules, and one of them is going to be the routing width. So if you go to Routing Width and then you go down further into Width, I'm going to set my minimum width to be 6 mils because that's the minimum that most board manufacturers will do without an upcharge. My preferred width will be 10 mils, and my max width for maybe some power routing will be 20 mils, even though this board doesn't really take a lot of power. And I'll click Apply, and we'll come back to this Rules Wizard after we do a Design Rules check. And I'm going to close this. So to start laying out, you can click this Interactively Route Connections button, and you start and then you just click, and every time you click it will place a wire down. So this is my 3.3 volt line. I actually want to make it a little bit thicker, so I'm going to hit Escape to leave the interactive routing tool, and I can double click on it, and I can change for each line segment the line width. So I'm going to make that 20. I'm going to make this 20. But here, where it enters the pad, I don't want it to be 20, I want it to be shorter. You can delete line segments and drag them together, like that. So I'll keep laying out my board. And I'm going to save the grounds for last, because I'm going to do a ground pour on the back side of this board. And so we'll treat those a little differently. So that might be a little too big. I bet that will cause us a DRC error, but I think that's okay for now. So I'm holding the control button and using the scroll wheel to zoom in and out. There are a lot of shortcuts for various zooms, and this just happens to be the one that I find the most convenient. So once you move a part, it doesn't drag with it your connection, but you'll have to delete and relay out. So as I said, I'm ignoring the ground routing for right now, but we can come back to that. One consideration that you might want to make is that you don't want acute angles in your routing. It could serve as a solvent trap, which is they use solvents in the manufacture of PCBs. So you can get around that by moving your component. It's just good design practice. It's not a requirement. So by moving this lower, I've avoided an acute angle. Sometimes you place more than you want and just select the segment that you no longer want and press delete. I've created another acute angle, and so I'll move something to see if I can get rid of that. Great. So we'll just keep doing routing. Be careful when you route under a component. If you need to later delete that trace manually with a razor blade, it will be kind of difficult. Also, when you're routing two pins one next to one another, it's a good idea not to route it in such a way that you won't have access to that trace in case you've made a mistake. So bring the trace up and over. There are a few ways that you can route on the bottom layer. The first one is to place a via first. Hit escape when you're done placing it, double click it, choose its net, and in this case I'm going to choose the net ground. Click the interactive routing tool. Start routing, and then after you've routed there, hit the L button to change layers. Once you've started routing, and now you're routing on the bottom side, and you can route to another via. So blue represents the bottom side. So if I undo that though, let's hit escape to leave the tool. And I'll go back to the top layer. I can also start routing, and as I'm routing, hit Control Shift and use the scroll wheel to scroll down, and that will automatically place a via, and then it will put me on the bottom side. So I'll do that one more time. So the first thing you do is you start routing on the top side. So hit escape and hit on the top layer. And as you're routing, hit Control Shift, scroll the wheel. You can place a via, and now you're on the bottom side, and connect to wherever you want to connect. I'm going to undo all that because we're going to treat our grounds a little differently on this board. So hit save. We're back where we started, and everything here is routed except for the grounds. So I'm going to go to Tools, Polygon Pores, Polygon Manager. I'm going to go to New Polygon from Board Outline, and here you can change its parameters. So double click on that pore, and I'm going to put it on the bottom layer. I'm going to choose the net to be ground, and here you have a few different options. I'm going to choose the solid fill versus a hatched or no fill, and I'm going to pour over all same net objects and click apply. You'll get a warning. Click yes, click OK, and here you'll see we're looking at the bottom layer and that there's a pour over everything that is the same net. And so the only same net via we have right now is the via or the pad for our connector. And if we look at the top, you can see here's our components on the top. And if we press L, we can re-enable the overlay, and so far this is what our board will look like. I'm going to hide the overlay. I'm going to go back to Tools, Polygon Pores, and I'm going to shelve the polygon. That doesn't delete the polygon, it just makes it so that you don't have to look at it. And I'm going to start placing vias to ground and connecting the various component nets to ground. So I'll place a via here, and I'll place a via here, and I'll put one here, and I'll hit escape. And so once again, you can place the via, and you have to set the net first to ground. So double click on the via, set the net, set it to ground, and now when you interactively route, you should be able to route directly to the via. So I'm going to do something a little differently for the other ones. So I will start routing, and I'm going to hit Control Shift and scroll down, and it will automatically put the via that I want. And to leave the tool, you can just right click. So I'll keep routing the various nets. Sometimes you're in the wrong layer, so just make sure you choose the correct layer that you want to route on. And I'll zoom in here, and I can see what connections need to be made. So we have a few more things to route. You might find that even at this late in the game, you have components that need to be moved. So I'm going to move this component, and I'm going to rotate it like that. And I'll delete these extraneous. And I can move this. And so now I'm going to route this ground. And I'll hit Control Shift, down scroll wheel, and you'll see that the via might move your traces automatically, and I'll hit Escape. And I'll do the same thing here, so I need to be on the correct layer. Control Shift, scroll wheel. Also, if you have a number pad on your computer, you can hit the star button. I'm just making this neater. Alright, we have a few unconnected grounds still, and unconnected 3.3 volt. So there's 3.3 volt, and this one last ground. Control Shift scroll wheel. Great. So now everything is laid out. We're going to need to go now back to Tools, Polygon Pores. Now we're going to need to re-pour all, and Tools, Polygon Pores, Unshelve. So restore the one. So it has these errors because you need to restore it first and then do a re-pour. A re-pour will re-pour around all of the recently placed vias. And so now you'll see that there's no errors. We can look at the top again. Let's move our overlay. If you ever move something by accident, just hit undo. Make sure that you've selected the component that you think you've selected. And it's a good idea to orient your overlays all in the same readable direction. And if it's too big, you can just come and change the size here. So I'm going to change this text height to 40 mils. And here I'll make this 40 mils too. So here's U2. Sometimes it's difficult to select just the component that you're looking for. There we go. If you double click it, you'll get this option. And I want to select just that, and I'll move it out of the way. So it's important not to put your overlay on any of the pads that you hope to solder to, but your overlay can cover, anything else pretty much that's not a hole and that's on your board. Okay, so at this point we're done with the layout. Make sure that you save everything. And now you do the design error rules check where you find out that you're not really done. So go to Tools, Design Rules Check, and it's going to check the default options except for the one with option that we changed. And you'll go through the errors and see which errors you think are actual errors and which errors you think are okay. So I have errors in 3 classes. I have an unrounded net. That's probably pretty important. I have some minimum solder mask to silver gap errors. And I have a silk to solder mask clearance. So let's go through these errors one by one. The most important is probably this unrouted net. I'll double click it. And it's saying here that this ground pin is not connected to ground anywhere. Well, that's a big mistake, so I'll go to interactive route and I'll do that same control shift scroll wheel and I'll place that and hit escape. So now we're on the bottom layer, but if we go to the top layer, we'll see that these grounds are now connected. But this error hasn't gone away. So to get that error marker to go away, you'll have to save it, Control S, Tools, Design Rules Check, Run Design Rules Check. And now you'll see that I have 61 warnings, but when I go through them, they're only in these 2 categories. So solder mask to silver gap. Let's look at one of those. It's saying that, the distance between this pad and the solder mask is too small. And if you Google that, you'll find out exactly what it means. Silver to solder mask warning Altium. So this rule helps identify narrow sections of solder mask that may cause manufacturing problems at a later stage, ensuring that there is a minimum width of solder mask across this board. This rule checks the distance between any 2 solder mask opening is equal to or greater than a user-specified minimum value. And so that's the key term here, that it's a user-specified minimum value, and that will be different from board manufacturer to board manufacturer. I'm going into Design, Rules, and under Manufacturing, you'll find minimum solder to silver rule. And right now it's 10 mils. I'm going to make that 5 mils. And I'm going to run the design rules check again. Alright, so that drastically reduced the number. Now, if you just change the rules and the manufacturer still can't make it, then you'll have a problem. So you want to change the rules only when you know that something will be okay. I know that this will be okay because the manufacturer will pull back the solder mask if they don't think that they can add it. So I have this silk to solder mask clearance and silk to silk clearance. Let's look at the silk to silk clearance. Oh, that's the wrong one. So go back to your rules and silk to silk clearance. Here we go. So the silk screen from this component is touching this one. That doesn't really matter. Your board will still get made, but you might not be able to read as you had hoped. So I'll just go through and move those 5 issues. And once again, the errors aren't reset until you run a DRC again. So these are all the same part, these rules. So I'm going to hit save, and I'm going to do tools, design rules check again, run design rules check, and now we should have just the one class of warnings left, silk to solder mask clearance. And let's Google what that rule means. So instead of silver to solder mask, it's silk to solder mask. Warning. Altium. So this is saying that we might get solder mask or silk screen on our solder pads. So it's saying here, you see that this might be too close for some manufacturers. Realistically, it should be fine. So let's change that rules, tools, or design rules, and that's also in the manufacturing section, and we can change that from 10 mils to 6 mils. We'll run our design rules check again. And we have 0 warnings and 0 rule violations. So at this point, let's click Save. Let's go to our project tree. We'll save our project. And you're ready to output the fabrication files. And you'll go to Files, Fabrication Outputs. And here you have a variety of different fabrication output files. And which output files you need is dependent on what manufacturer you use. I often use PCBWay, and I will just search for their Altium design rules or Altium fabrication. And I'll click this link, Generate Gerber Files from Altium. And I generally start here on step number 2. And this will lead you through all of the steps to output the files that they want. Now, a different manufacturer might have a different requirement of what type of files to use, and so it's always important to find what your manufacturing house wants. I hope that this was informative. If you have any questions, please ask your TA or come to Deck and Lab. Thank you. Bye.